43, lots and lots of forces on this then, aren't there? So we've got P here with mass 3 kilograms, so force going downwards 3G here. There'll be some normal reaction here, that is RP, and it's being pulled this way by some tension in this cable here. That tension is stopping Q moving as well. So we've got Q in here, this is Q, and Q's got a force downwards of 4G there, and there'll be a normal reaction for Q as well. And it's being pulled by this 45 newtons here at an angle of 40 degrees. So let's split that up into its two parts. So here I've got 45 cos 40 degrees, and pulling up there 45 sine 40 degrees. You think that would be enough, but no, we've even got some friction as well. So we've got friction coefficient mu on Q. So this one here has got some friction, and this one here has got some friction as well. That's some friction at P, and that is the force diagram. But then part A doesn't even need it. So part A says find the acceleration. Well, it starts at rest. We've got the time of 3 seconds, and it says it travels a distance of 5 meters. Find out what your acceleration is. So I'm just going to use an S equals ut plus half at squared there. So I've got S is 5. That bit's nothing. So I've just got half times A times 3 squared. I've got 10 over 9. I've got the acceleration to be 10 over 9. And let's start making some effort with this diagram here then. Right, looking at that one there, I can see what that normal reaction there is straight away, can't I? Because I've got 3G going down, so there must be 3G going up there. So I'll put that one on. You can just about see at the top there. That friction then, because we knew that the friction at P was mu, so the friction there is going to be 3G mu. I'm going to work out what this friction is as well, but it's not quite as simple. So at Q, I'm going to look at the forces going up, and the forces going up, I've got the normal reaction RQ plus the 45 sine 40 minus the 4G equals 0. And so that means that the normal reaction there is 4G minus 45 sine 40. I'm going to tap that in, and I've got 10.27 there. So if that bit's 10.27, then that friction there, and they told you that one there, the coefficient of friction is 2Q there. So I'm going to double that. So that bit there is going to be 20.55 mu there. Right, let's go and continue this. So we're now going to go horizontally at Q. At Q horizontally. What's pulling it to the right? You can't see my diagram at the top there, but you've got your own. So I've got 45 cos 40 pulling it to the right. I've got the tension pulling it to the left, and I've got that friction that I just put on there. So that's 20.55 mu there. And of course, going to the right, that equals mass times the acceleration. The mass of that one is 4, and the acceleration we did earlier is 10 over 9. Let's do the same thing at P. What's pulling P to the right? Can you go back up again? P, the only thing pulling it to the right is the T. T, take away that bit of friction there, equals the mass times acceleration again, 3 times by 10 over 9. Two equations. We don't know what the tension is, so let's add these two things together. So I've got, right, that 45 cos 40 minus t plus t, and then minus, so if I've got 3 g's and the extra 20.55, I've got 49.9 mu there. Add those two things together, I've got 40 over 9, 30 over 9, so I've got 70 over 9. So I can finish this off now then. Tap that in, take off that, divide by the 49.9. I've got 0.534, I think, but I'll pause and just check it. Yep, that looks good. 0.53, well, I've got 535 actually, haven't I? 535 there, if I did it more accurately. So part C, don't worry, there's not too much to go. Part C, I'm just going to put it into here. So I've got T minus, and we'll put the mu in there. So I've got 0.534 times by 3g equals 30 over 9. Just add that to both sides, and I can see that the tension's 19.045 or 19 newtons. Part D says, how did you use the inextensible thing in the calculations? So if it's inextensible, the t's are the same, but more importantly, acceleration same for P and Q. That we use the acceleration there and there to be the same. We could only do that because it was a light inextensible string.